Now, if we assume that, then we can do the equivalent principle of consciousness. So let's start with two systems, right? One system will be Alice, our conscious human. The second cognitive system will be zombie Alice. I call it artificial learning intelligent conscious entity, or in other words, capital letter Alice. So we know about Alice and the zombie Alice that they measure the same results for every physical measurement. So they will measure that they have the same reports, for example, they have the same cognitive system, the same dynamics, the same representations, everything is the same. And then because of that, we can use here the relativistic principle and say the follows. So I have two observers, but they measure the same results, Alice and Alice and the zombie Alice. So it means that I have equivalence between the systems, those two cognitive systems. And then it means that I can use the same they use the same laws of nature, and then I can do what Einstein did, and I can infer the laws from one equivalent system to the other. So because we assume that there is some kind of law of physics that explain consciousness, it means that the same laws that Alice has, also zombie Alice has. So also the zombie Alice now will have consciousness, just because of the relativistic principle. There's nothing above and beyond the observers. So what it means is that according to the relativistic principle, zombies cannot exist, because now our zombies actually have a phenomenal consciousness. But now, because of that, let's examine the zombie. We thought that they didn't have consciousness, and they do have qualia. So what is the qualia in the zombie? So, you know, this is physics. So in the end of the day, we need equations. I did all the, hard work of the equations. I don't have the time to go into it right now, but you can see it in the paper or ask me later. But in the end, one thing that we proved is that qualia is equal to the complex representations of phenomenal judgments. If you remember, we talked about it before, the I see an apple, for example. But this is true only in the frame of reference of the zombie. It's not true everywhere. So again, because there's nothing above and beyond the observer, if the observer has something that is like to be, then this observer has phenomenal consciousness. It is not something, okay, it is not something, he's not delusional about it. But it's true only on his frame of reference. So now everything, there is no absolute truth anymore. Let's say all of our truth are according to the frame of reference that we are in. So let's then see what is the solution then for the question that we started from. We have Bob, and Bob sees an apple, and that's why I experience an apple. And then we have Alice, and Alice is measure only that Bob has only neural representations. So, and we ask, how do we do this transformation? But now we see that we don't need to do this transformation. This is a wrong question. And there is an equivalent here. The third person point of view and the first person point of view are just two different frame of reference that describe the same underlying reality from, and the only different are the measurements that both of them can do. So different measurements create different properties. And this is how we bridge the gap. And you can ask me, okay, so how come we have those two different frame of reference? What is the difference in the measurements between them? The difference is that when we say third person frame of reference, we mean that we measure everything through our sensation subsystem. and our sensation subsystem can measure only the physical substrates. And that's why Alice measures the physical patterns of the neural activity. But first-person frame of reference is a different measurement. Over there, the cognitive system measures its own representations. So when the cognitive system measures the representation, it doesn't care what is the physical substrate of that. The only measurement here is about the role and the interaction between those representations. And that's why this different measurement create a different property. To this property we call qualia. So this is more or less the idea here that, so it's a physicalist theory, but it's not a reductive materialism, because we don't say here that neural patterns create consciousness. It's the physical measurements, and different measurements create different properties. And also, now we see that phenomenal consciousness is not private. Again, we developed an equation, a transformation that takes us from one cognitive frame of reference to the other cognitive frame of reference. And in order to do that, what we need to do is to change the dynamics of the cognitive system. And this is how we can change, let's say, from one frame of reference to be in the same frame of reference. So now both of them can measure the same qualia. So a prediction here will be that if Alice and Bob could have the same dynamics and share these dynamics, then they can share their own phenomenal consciousness. Now, it sounds like science fiction, but actually there is something similar to that in reality. Those are Krista and Tatiana Hogan. They are twins that live in Canada, and they share their brain, they share their thalamic bridge. So some representations, they share them, and then they don't measure those representations just as from a third person point of view, but they actually share them as what they are, what their role is. Okay, so to conclude, so phenomenal consciousness is not absolute, it's relative. There is equivalence between Alice and zombie Alice. So zombies cannot exist, and different measurements create different properties, as we just saw. I want to thank Zakaria Nime that helped me to write the paper. The paper soon will be published, by the way, in Frontiers of Psychology. It's in press. And the final thing is that I finished my PhD, and I would like to continue and develop this theory. So if you want me to work with you, I'm searching for a postdoc position, or if you know someone that would love it, please let me know. Thank you very much.
Thank you, Nir. I'll go ahead and bring the microphone to you, but I'll take the chair's prerogative and ask the first question. So what is the coordinate system that the frame of reference is in? Is it space-time, or is there some other dimension or variable that you would need in the different relativistic frames?
Great question. So here we are not in space-time, only the inputs are, let's say. Now we are in a cognitive system, so our dimensions here is the state space of the cognitive system. So there is some kind of state space that we need to understand what are exactly the axis of that. And all the states, each state there is a different representation. And then we map from those representation in one cognitive frame of reference to the other.
Hi, James Dreesen. In your Einstein train car problem, you skip the part where they each have a laser light gun and shoot it at the same time, and the laser light goes out exactly together. So why did you skip that part of the analogy? Just because it didn't help that your...
So do you mean where, in the equivalent principle that I told you about, or?
No, in physics, the Einstein train problem, he goes through the dropping the ball and the throwing the ball, and that's all right. But if the train's going by and they're two at the same place at the same time and they shine a light, then the
yes.
light goes out at the exact same speed for
Yes,
both
now I understand.
observers.
Yes, you're right. In special relativity and then general relativity, we know that the speed of light should be constant. And now here it's a different thing. I hope I didn't say it in the beginning, but I hope that you see that we are not in relativity theory of Einstein, right? We don't speak here about light, about space and time. We speak here about cognitive frames of reference. So here there is just no analogy yet, at least, to a constant thing like the speed of light. Maybe there will be in the future, but for now I didn't see anything like that.
Well, then I will be quick. In signal theory, you can have a wave, but if you have multiple waves that create an interference pattern, that no wave goes faster than light, but you can create an interference pattern that propagates and begins moving faster than the rest of the wave. And so I think there is something there that nothing's moving faster than light, but yet a propagation interference is moving faster than light. So I think there's something into that, to the physics of that. Look it up, I guess.
Okay, I will look it up.
I hate to be the one that says, this is my work and this is your work, but you're doing your work, but there is
Okay.
faster than light, and so that could have something to do with your consciousness hard problem.
Okay, I will check it out. Thank you very much.
Thank you.